Hi everyone. This video is the final project presentation for the class Big Data Analytics at Columbia University. Our topic is forecasting S&P 500 index by using the New York Times dataset. My name is Lee, and in this video, Yusen and I will give you the presentation. So let's start. First, here's an overview of our project. Since nowadays a lot of economic scholars and hedge fund investors tends to pay more attention to the use of social media data. And after we went through some previous research papers, we found that last research paper did text mining techniques by using the data from mainstream media. So triggered by these ideas, we decided to use the New York Times data as an indicator and predictor to forecast the fluctuation in stock market. In specific, we are going to forecast the S&P 500 index. So first, we think that daily news could be a good indicator to predict the stock returns. And also, we think there could exist a sort of causal inference between the daily returns and the daily news. So we decided to use some classification techniques and combine them with the time series analysis so as to make better predictions and help investors make business decisions in the future. So we collected our data from the following two major sources. Firstly, we download the S&P 500 returns from the year 1950 to 2016 from the Yahoo Finance, which including about 17,000 data trading days of the daily returns. And afterwards, we collect our news data by using the New York Times API. We typically collect around 800 data files, which including almost 3 gigabytes. So here's a brief introduction of the API that we use. And as you can see, here's the official website of this API. And firstly, we were trying to use the article search API, but the challenge of this API is that we can only make at most 1,000 calls per day. But in our dataset, it was required us to make more than 10,000 predictions. So we found another API called Archive, which allow us to make which allow us that we can only make one call and get all the news data from this entire month. So after we collecting the data by using the this Archive API, as you can see, here's a brief look of the data format we collected. So we were only looking into the headlines and leading paragraph of each article, and by calculating and testing the frequency of keywords from headline and leading paragraph of each article, we could generate some algorithms, and we will talk about it later.
And after reading raw data from CSV files using R and PySpark, we then did data merging, cleaning, transforming scenes to get our data frame and Spark RDD. And in the feature engineering process, we firstly used a tokenizer to deal with text data, and then we used hashing TF to calculate the TF term to save memory and improve efficiency. And after that, we applied TF-IDF algorithm to extract features, and we can get the sparse matrix. And in the modeling process, it consists of two parts. One is predictive model. We'll try a lot of machine learning algorithms here. And another one is exploratory model. We'll do time series analysis here, and the model we use is LSO. Once we got the results, we can build a practical scenario combining these two types of models together. And here's a screenshot of our feature engineering process. These are main steps, and the weighted frequency matrix is the input of our model. So far, we have found two challenges. First one is some ensemble models, such as random forest, are really time consuming. It may take a long time to get results. And another problem is that it's hard for Spark to read the whole data set and save it. So we decided to split the whole data set by every 10 years, and we'll run algorithms on each sub-data set. Our findings are shown here. For the predictive model, EBS is easy to have overfitting problem, and SGD classifier and logistic regression are stable and accurate. But as for the average accuracy and ROC AUC value, we decided to use SGD classifier. And as for the random forest, we haven't got the result yet because it's really time consuming, and so in practical, I think we think it's not a good choice. For the exploiter model, the left two figures are the results from Lasso model when considering previous returns, and the right two figures are the results without considering previous returns. So obviously, we can have better model when considering previous returns, and we can and if you can see the distributions of error rate, the left two figures tell us that the model has less error rate. And we took logistic regression as an example to compare these two types of models. We can see that more feature is better, which is obviously, and if we can integrate these two types of model together, it will helpful for either predictions or explanations. Let me show you the demo. First, we open the terminal and enter the Jupyter notebook. It may take some time. Okay. And here's the code for the demo, and the kernel is starting here. Okay, let's start it. If we run the code at one time. Okay, while waiting for the results of the model, let me explain the data we're testing first. And the data we're testing is from November 30th this year to December 6th. And we can see on the first day, the SP500 index went down, and in the following 4 days, the index went up. Okay, now we have the results. We can see that the predictions are up, up, down, up, and up. And as we see before, the real values are down and 4 ups. And the accuracy is 68%. We can see the prediction is not bad.
So as for conclusions, among those predictive models that we tried, we conclude that the SGD algorithm is the best choice to predict the S&P 500 index. And as for the exploratory model, we found out that the daily news could have a big influence on the stock market as well. The business value behind our project is that usually most of the financial data are structured, but in this project, we used more unstructured data from the third-party data source, and also we integrate machine learning algorithms and time series analysis together to help us make better decisions. So as for the next steps, first, when we were collecting the data set, right now we collected all the news come from all different kind of sectors, but some of the news that might be related with sports and entertainment could have less influence on the stock market. And in further study, we would only collect those news that come from the financial sectors so as to improve the accuracy of our model. And secondly, we could also collect more data from some non-official social media platforms such as Twitter and Facebook. Eventually, we like to build a pipeline to integrate all the useful models and algorithms together to help investors make better decisions. That's it, and thank you very much for watching this video.